Hi everyone, and welcome to Maths Revision with Jov. Today we're solving the problem A, B and C are spheres. The volume of sphere A is 125 centimetres cubed. The volume of sphere B is 27 centimetres cubed. The radius of sphere B to the radius of sphere A is the ratio... the radius of sphere B to the radius of sphere C is in the ratio 1 to 2. And it wants us to find the ratio, the surface area of A to the surface area of C. I think the most logical approach to this problem is to assign each sphere a radius, and then we can just write a few formulas about them, a few expressions if you like. So we can say that sphere A has radius RA, sphere B has radius RB, and sphere C has radius RC. I hope you can see those all right. And now we can write a few things we know about them. So the volume of sphere A is 125 centimetres cubed. The volume of any sphere is 4/3 pi r cubed. But in this case we're looking at RA, and that is going to be equal to 125. Similarly, we've got the volume of sphere B being 27 centimetres cubed. So we've got 4/3 pi RB cubed is 27. We can actually go ahead and solve for R if you like, but it is still, it's fine to do this other trick. We can actually go ahead and just divide the two so we get a sort of ratio, because the question deals with ratios. So if I want to go ahead and divide 4/3 pi RA cubed by 4/3 pi RB cubed, we actually get that the 4/3 will cancel out and the pi's will cancel out. So we get RA cubed divided by RB cubed. We can actually go ahead and simplify this even more, because we've got both the numerator and the denominator to the third power. So get RA divided by RB. We can raise this all to one single power, which is 3. We must remember to balance the equation, so we actually have an equation. So we've got that this RA divided by RB cubed is just this ratio here. 125 divided by 27. Now notice that both of these numbers are actually cube numbers, so we can simplify this. This is just, well, the cube root of 125 is 5, and the cube root of 27 is 3, and this is all cubed, which means now we've got both sides of the equation having a power of 3 in them. So the ratio of RA to RB is just 5:3. We've actually found the ratio of RA to RB now, and we can go ahead and solve for B, and you'll see why this is important. So we can multiply both sides by RB, so we get RA is 5/3 RB. And then we can multiply by 3 and divide by 5 to get the RB on its own. So we get RB is equal to 3 RA divided by 5. Great. We are given that the radius of sphere B to the radius of sphere C is 1 to 2, which means that RB divided by RC is just 1 to 2, so 1/2. Similarly, we can solve for RB in this case as well, and that's much easier. RB, we can go ahead and multiply both sides by RC. So we get that RB is just RC divided by 2. Now, we found RB in two different cases. So we've got that, we can set these equal to each other now because they're both RB. So 3 RA divided by 5 is equal to RC divided by 2. Now, because we're looking at ratios, we should probably find the ratio between RA and RC. We can go ahead and do that quite easily. So what we're going to do is we're going to multiply both sides by 5 and by 2 to get rid of both fractions. So we've got RA and divided by 5, so the 5 goes away, but we're also multiplying a 2 as well. So we actually get 6, 6 RA is equal to, and then multiply this by 10 as well, so we get rid of the 2, but we also have a 5 to multiply by, so we get 5 RC. Now we can go ahead and find the ratio of RA to RC. We can do that by dividing by RC on both sides, and to get rid of the 6 we can divide by 6 as well. So we get that RA divided by RC is 5 over 6, and what that means is the ratio of the radius of sphere A to the radius of sphere C is 5 to 6. It's in the ratio 5 to 6. So now I'm going to go ahead and write a bit lower down here, because we need to find the ratio of the surface areas. The surface area of a sphere, which I will call, I don't know, I'll call it S, and then A, surface area of sphere A is 4 pi r squared, but it's RA. And the surface area of C, so SC, is 4 pi RC squared. We want to find the ratio, so we want to go ahead and divide them. So I'll just write that there as I'm dividing them here. We actually get that the 4's cancel and the pi's cancel. So we're just left with RA squared divided by RC squared. This is just equal to RA divided by RC all squared, if you can see that. But we've found RA divided by RC already. This is just 5 over 6, so we get 5 over 6 squared, and that is just 25, because we're squaring the 5, divided by 36, because we're squaring the 6, which means that the ratio of the surface area of A to the surface area of C is in the ratio 25 to 36. And I hope that helps.